I got great news. So today we're going to start talking about the fundamental theorem of calculus. Fundamental theorem of calculus basically says if you have a defined definite integral that you can do the antiderivative and then plug in the bounds of your integral to figure out what that area is rather than doing that limit notation that we did before. Okay, so next week on your quiz you're going to be asked to use the limit definition of the definite integral for one question. Okay, so you still are going to need to be able to do this. Okay, but other than if I don't tell you to use that limit definition, you can use the fundamental theorem of calculus. So we're going to do a couple of examples using that fundamental theorem of calculus and go from there. Okay? So if the 2 and the 1 weren't here on this question and it was just the integral of x squared minus 3 dx. Okay? What would the antiderivative of x squared minus 3 be? X cubed over 3 minus 3x plus c. Okay? What the fundamental theorem of calculus tells us is if we evaluate that antiderivative and subtract my upper boundary minus my lower boundary. Is everybody with me? Okay? That gives me the same thing as the limit definition would do. So then I'm going to do 2 cubed over 3 minus 3 times 2 minus 1 cubed over 3 minus 3 times 1. So let's see, this is 8/3 minus 6 minus 1/3. I'm going to distribute that negative through, so this will become plus 3. Seven thirds minus, I think it's negative 2/3. Now, if I say I want to see analytic support, which I will, okay? If I ask for analytic support, I need to see at least the antiderivative and how it's getting evaluated. Those are all things I would expect to see, okay? The value of the antiderivative, how you got the first step of your numeric equation, okay? And then from there, whatever. So, now, that being said, can we check our answers pretty quickly? How would I check my answer on this? I would use Math 9. Everybody okay? So, there's going to be plenty of opportunities for you to say, yeah, I got this right or wrong. If you're throwing it into Math 9, you're getting a different answer. I'll help you find your mistake. That's my job. Cool? All right. So let's look at some other ones. You guys want to do this one next? Sure. Thanks. I would write this as 3x to the 1/2, by the way. So the first thing I would want to see is the antiderivative. What is the antiderivative of 3x to the 1/2? Let's see. What would I do with that exponent? Take it up by 1 and then multiply by its reciprocal. So what's 1/2 plus 1? 3/2. So I'll have x to the 3/2 times its reciprocal. And then the 3 out front. And that's what I'm evaluating from 1 to 4. Which I would write as 2x to the 3/2. I believe 4 to the 3 halves is 8, so this should be 16. So my final answer, 14. We'll start to make it a little bit worse. Why is this one annoying? We have to split it. Why do we have to split it? Because of absolute value, yeah? Okay. But, like, not just absolute value, because, like, before when we've dealt with absolute value, we kind of split it up into less than 0 and greater than 0. This one's a little bit messier because we did that because the vertex of that absolute value was at 0, yeah? Okay, where's the vertex of this? It's at 1/2. Does everybody see? Because it's going to be wherever the absolute value equals 0, that's where your vertex is going to be, okay? So in some respects, I'll use this one because it doesn't matter for this. This isn't as good as the other one, but it'll work for this. So I'm going to make my x min 0, my x max 2. I'm looking at this graphically, right? Okay. I'm doing that because I'm integrating from 0 to 2. Those are the x values I'm interested in. Okay. And since I know, I'm going to make, just to get a better view of this. Let's look at this picture. There we go. Interesting. Stability. Okay. All right, you guys. So if I ask you, like, so picture-wise, we can kind of see this is looking here, where this is 1/2, yeah? All right. If I asked you, what is this equation? What would you tell me?
1 minus 2x.
I'm going to call it negative. This side is negative 2x plus 1, same idea. Okay? Where it's the negative of what's inside the absolute value, and then over here we have 2x minus 1. Okay, so to do this particular one, we're going to have 2 integrals. So from 0 to 1/2, we'll do negative 2x plus 1 dx. And then, oh, I'm not doing a good job of color coding this, but that's fine. Now, that being said, I might consider not integrating this. I might say this is a triangle where this is 1/2, this is 1, so the area of that triangle is 1/4. Like, I might just use geometry equations to get me there. This is 3/2, and then if I plug in 2, this is 3. Do you guys see what I'm saying? And so, like, we should get 3 1/4 as our answer. Everybody get what I'm saying there? That being said, you know, okay, it doesn't matter. I'm going to do it both ways. So, you guys, what is my antiderivative of negative 2x plus 1? negative x squared plus x. I'm going to evaluate that one from 0 to 1/2. Plus, this one will be x squared minus x evaluated from 1/2 to 2. Oh, this area is not 3. This area would be 9. Two and a half. You ready to look at another one?
Is it never possible to directly take the antiderivative of the absolute value or not, just because it's inherently like a piecewise function?
So, like, if I had taken this from, like, 3 to 5,
Then you wouldn't have to.
you wouldn't have to. It's when you have to go over that split
There
domain.
isn't like an antiderivative rule for it.
There's no.
Yeah.
Because there's no derivative of absolute value. Like, the derivative of an absolute value is, the absolute value of a linear, which is also a component of you. Like, there's nothing that says that this has to be, like, this could have been x squared plus 3x plus 2. And what that graph ends up looking like, so let's say this is the non-absolute value. The absolute value of it would be,
Yeah.
right? But then you still have like a split domain kind of thing going on. You would still have to rewrite it as a piecewise function.
3 instead of.
Yeah. Okay. All right, y'all. What is the antiderivative of secant squared? In other words, what function has a derivative that is equal to secant squared? Tangent. Okay, so this is tangent x evaluated from 0 to pi over 4. Again, I'd like to see that antiderivative statement and where we're evaluating it. The next thing I would want to see is, like, to do that evaluation, see that numerical step after you plug it into both of them. Like, plug both bounds in. And from there, what do you get? You guys, what is the tangent of pi over 4? 1. Tangent of 0 is 0. So overall, this is 1. See, isn't this fun? I think it's fun. Hey guys, what is the antiderivative of 1 over x? Again, a reminder, that is me saying what function's derivative is equal to 1 over x. ln of x. Evaluated from 1 to e. Okay. ln of e is? ln of 1 is? Done. So much, did you guys want to do the, you guys don't want to do the limit of this? No thanks? I think we run into an issue. I don't know that I know how to. Let's see, it would be,
So everything would just, wouldn't it just be a reciprocal of like everything?
Well, like, so your delta x would be 1 minus e over n, right?
Yeah.
Or no.
E minus 1.
E minus 1 over n. And then let's see, your c sub I would be 1 plus k e minus 1 over n.
It's the f of c of I. That's
And the f of c sub I,
Is it n over k?
yeah, I would do that, right? And it would be n over n plus k e minus 1. And then you would be taking the limit as n goes to infinity of the summation k equals 1 to n of n over n plus k e minus 1.
Is it over 1 plus k minus 1?
Say that again? Well,
Should CI be 1 plus?
it's 1 plus that. And then if you're going to turn it, the f of c sub I is reciprocal, you need to write it as one fraction. So I turn that 1 into n over n.
Oh, okay.
And then times e minus 1 over n, right? Yeah, you still have that k in the denominator, which I wouldn't know what to do with, yeah?
I mean, couldn't you just do it the same way? Just in the denominator?
Or could you, like,
I don't know that I believe you can.
you couldn't take the reciprocal of that whole, like, k times...
I don't think you
or
can.
N plus 1 over...
I don't think you can. Because, like...
Well,
I don't think...
if you just had a summation of 1 over k...
You'd have, like, 1 plus 1/2 plus 1
Right.
third.
Harmonic series.
So then to add all of those up, you would have to get a common denominator. So it would be it would be n factorial. This is a fun little. So the question is, we